welcome. I'd like to give you a quick update from my video I did posted yesterday. It might be interesting to see. So the importance of replacing a signal generator is important, but we need to have exactly the same functionality as we had it with a signal generator. So from my Class B amplifier, or the driver circuit if you want, I go out with a capacitor directly, or I can go out open to a secondary Tesla coil if you want. We're not using a primary, we don't drive a primary, I drive directly a secondary. I can drive any kind of coil I want, and I don't have any problems with the high voltage I generate, because here on the bottom where I connected, my voltage is at a low level slightly above the voltage rating for my amplifier. But this can be easily controlled via a Zener diode to the 15 volt, which is the maximum I can output here from my driver with a Zener diode and a small resistor to keep that in check. So we have my circuitry, and the very interesting part about that is this is self-tuning. I will go into these details on my member website. When you connect to a secondary coil, when you can connect to a coil system, it does not need to be an air coil. It works also with Farad or transformers. It does self-tune. It's a very interesting phenomenon. It's a bit tricky, then once it's locking into the frequency, it stays there. However, I still have control with my fine-tuning potentiometer, and I can see that here I have some LEDs here on that side. No, LEDs, so high voltage glim lamps, if you want, to show you that high voltage AC existing. And there's another phenomenon. If you have a dielectric field, that means we have high voltage out here, and I have this lamp here. So this lamp will show you it's a sensor lamp. It's just out of curiosity, just to demonstrate what happens if you use a Tesla coil and you energize it. And I have done that many times in my home in the UK. And technically I switch off TV in the living room while I was in the garage. So it is kind of dangerous in terms of for electric circuitries in your environment. I actually, with my Tesla coils, did trigger the house alarm of a couple of my neighbors by using it. So just to demonstrate here, only on this small device, it's 12 volt coming in here. It's a sensor switch. If I switch that on, I can do that like that. But if this coil is energized, I just need to change the field with my hand and it will work. Now let's have a look. I have now energized the coil, and as you can see here, the lamps, the LEDs on that side, and watch the screen as well. You see the amplitude. If I go too close, I will switch on the lamp with my hand. So my hand is changing the dielectric field with the capacitance I produce, or I change the environment with. If I would touch now this screwdriver, it would trigger the hand. But what I want to show is, if I go with my hand in here, I switch on the lamp, I can switch it off. I can do the same here. So this, what I demonstrate here is the expanding dielectric field, where a sensor, it can be any electronic circuitry in your environment. Once you are using a Tesla coil and energize it, you are expanding the sensory to that level of the reach of a Tesla coil. That's very, very important. That's why high voltage devices need to be insulated, need to be encapsulated as possible. But because of the near field effect, it's almost impossible to do that. That means even if you put it in a Faraday cage, it will not help you. It will get through, and it will trigger devices with sensory systems. Another thing I also would like to mention, this system is depending on the load in its environment. These two glim lamps, are actually a load. So if I take more energy out of this one, I switch this one off. So when we look at Don Smith, who uses a lot of coils, and I used that, go 8 years back in one of my experiments where I used a lot of this coils literally stacked up and trying to receive energy. Some more I put and some more I take out, the others don't get this energy anymore. So this is actually not correct how he said he can have 5 coils around and all will receive the energy. There is a dependence to the field. Once I get one consumer locking on that field, like this one, you see it on the screen, I disable this screen. So that is confirming it is not correct what Don Smith said, that I can use many consumers because they are creating a relationship in that field to your transmitting coil, and because of that, this one-to-one relationship, there is not enough energy for a second consumer available to consume this energy. So that was only a quick update and out of curiosity to show you something like that. What you can do with the circuitry, with the replacement of the signal generator to this class B, and on this driver circuit there would be an additional class B circuitry attached, which then run with high voltage, where we can drive the much greater loads for our application. Thank you.